Good morning. I'm Dave Konecki, Executive Editor of Farm Equipment Magazine. Welcome to today's webinar, which is a joint effort of Farm Equipment and No-Till Farmer Publications. It has been developed to address planter setups, tools, and technologies for both the no-till farmer and equipment dealers who work with no-till farmers. Today's event is brought to you free of charge, courtesy of Martin-Till, a leading manufacturer of planter attachments and tools. Today's presenter is Phil Needham of Needham Ag Technologies. Phil has more than 20 years of experience working with farmers and manufacturers to improve their no-till planter setup knowledge and understanding. He also has 7 years of college and university education in soils and crop production. Phil's practical experience and research have helped farmers increase crop yields and boost profits, as well as farm equipment dealers by teaching them about proper maintenance and adjustments that are essential for planter attachments. Before we turn the controls over to Phil, we have a couple of housekeeping items to cover with you. On your screen, there is a white arrow in an orange box. You can click on the arrow and choose Question to open up a question field. This will allow you to submit questions at any time during the presentation. Time permitting, we will look to answer as many questions as possible following the presentation. If we don't get to all of the questions, we'll send the remaining ones to Phil so he can answer them. We'll put those answers up on our website along with the archived video replay of the webinar so you can go back and review it when you'd like. If for any reason your internet connection or our connection should happen to fail at some point and it looks like the webinar has been interrupted, just go back to the email you received earlier telling you how to join the webinar, and you can re-enter the webinar in that way. Okay, we're ready to go. Thanks again for joining us. We will now turn over the controls to Phil Needham to begin his presentation. It's all yours, Phil.
Very good. Well, thank you, Dave. Well, good morning, everyone, wherever you are, and welcome to the Put in Your No-Till Planter in Position to Sow Seeds of Success webinar. I'm going to be splitting the presentation here this morning into 4 different components. I'm going to be spending just a few minutes with regards to an introduction, giving you maybe a 20 or 30,000 feet elevation perspective of what's going on in the industry, where things are going, where things have been, etc. Then I'm going to spend some time, as you can see, with a second topic, discussing planter setup. Then I'm going to move on to no-till attachments on a planter to set up a planter to effectively and efficiently no-till. And going to round off the event this morning with fertilizer placement. So without further ado, I want to spend just a moment on the introduction section. So I came over to this country in 1989, and it seems like time flies, but back in '89, there was still a lot of conventional tillage, deep conventional tillage, disc chisels, discs, etc. And there was a lot of fields that looked something like this. A lot of tillage, a lot of energy spent, working the soils, a lot of moisture loss. And as a bottom line, some of the seed beds wasn't the greatest. And you can see in that example behind the planter, you know, there's some fist size or bigger clods. And trying to establish, you know, corn, soybeans, or other crops into a seed bed that looks something like that, especially in absence of a rain that followed planting, was really a challenge because, as you can see in this environment, not a lot of moisture there, a lot of dust, etc. So following a 3 or a 4-inch rain, and it seemed like we're getting more and more bigger rains all the time, you know, this amount of tillage, the lack of surface residue, the combination of all of the above in combination with steep slopes, long slopes, as you can see, was causing a huge amount of soil erosion, soil loss, nutrient loss, etc. So there was obviously a trend, and still is a trend, towards vertical tillage, and there's definitely a place for vertical tillage, especially in more northern regions. But I really feel a lot of these regions that are using vertical tillage could probably switch to no-till and achieve most, if not all, of the same benefits of vertical tillage. The reason I show this photograph in particular is obviously showing the vertical tillage tool by means of a prompt for the topic, but look at the residue distribution, or the lack of residue distribution. And it seems like whenever I travel around the country working with different farmers, I continue to see challenges with residue distribution at harvest time. And vertical tillage tools such as this really don't help that topic very much. So I would be amiss if I didn't at least mention that harvesting equipment still needs to be configured and adjusted to spread residue as evenly as possible at harvest time. Here we've got a new combine, new head, nice crop of wheat, but it appears in this photo that the combine's spreading residue over maybe 25 or 30 feet of the 40-foot head. That's not going to be good for long-term no-till. If you've got heavy streaks of residue, the soil is obviously going to be cooler under the residue and warmer in absence of residue. So successful long-term no-till absolutely begins with good residue distribution at harvest. So this is our plan. We do research, do a lot of strict trials, replicated trials, look at different things. So it's just what we use for our research. Basically a Kinsey 3000 planter set up for no-till. So we've got most of the attachments on it. We've got row cleaners, fertilizer openers, RID tires, spike wheels, drag chains, and then we've got some of the more advanced things such as the Precision Planting 2020 system that really has shown us a lot and taught us a lot about the dynamics of a planter unit, how it works, where it perhaps doesn't work from a point of view of many different areas. And you can see towards the left-hand side of the photo on the planter bar itself, there's a 100-pound green weight hanging to the toolbar. Just one simple, very simple illustration of what helped us in a research environment with the 2020 monitor was the fact when we first started running it, when we first equipped it with a 2020 monitor, we realized that the left side, as you view it from where you are, didn't have as much downforce on the two end openers, and that was we found as a result of the friction drive. It has one friction drive wheel that you can see directly above the weight, and that was actually subtracting around 100 pounds of weight from the two end openers on that planter. So we had to add a weight to compensate for the friction drive, as you can see in this image. So just a lot of little things. The 2020 also taught us differences in field conditions, soil types, and how that influences down pressure, especially on end rows where trucks are turning and the ground's more compacted and it's more of a challenge to get the opener engaged in the ground to a consistent depth, so whereby the gauge wheels are constantly on the soil surface. So a lot of things going on in that photo, but it's obviously a good place to introduce some of the topics and where we're going. So this is a no-till field, long-term no-till, heavy residue on the soil, which presents a lot of challenges that need to be discussed here this morning. So we're still seeing, or we are seeing a lot of advantages with cover crops from a point of view of just reducing soil erosion, improving quality, building organic matter, moisture retention, and everything else. But some of these cover crops, despite all of the advantages, do present greater challenges from a point of view of getting crops in the ground. This is a newer 1250 case, as you can see, totally equipped to no-till into, in this example, annual ryegrass. Okay, and we're obviously an advocate of different mixes, but in this particular example, this was just straight annual ryegrass, corn back into corn environment. And you can see there's weights on the end of this planter toolbar also. So another good example, and this grower is using the 2020 system also, and he found that in absence of having markers on the wings, this, in addition to a lot of planters on the market, really struggled to achieve consistent down pressure out towards the wings, especially with markers, without markers, I'm sorry. So especially in no-till soils, especially harder clay soil types, we're struggling to get consistent down pressure, and weight is often required to keep the weight on the toolbar to enable it to be transferred to the row unit. And down the road, you know, I'd like to see a lot more innovations on planters. The Delta Force system, that Precision Planting, in addition to others that are available on the market, are very useful. They're giving us individual down pressure adjustment, sometimes measuring it hundreds of times a second, making individual row by row adjustments all the way across the toolbar, because a lot of these central fill planters have a lot of weight in the center and the wings are light. So just adjusting weight, hopefully transferring it out to the wings and adjusting weight on a row by row basis is pretty important. So as we continue on with cover crops, last report I saw suggested that there was between 27 and 29 million acres of cover crops within the US, and I'm sure that number has grown. I think that number is 2 years old. So a lot of advantages to cover crops, and a lot of producers are beginning to adopt them and should if they're not already. So what we're trying to do in this example, heavy cover crop, corn into corn, what we're trying to do here is to part that residue. We're not wanting to move soil, but wanting to part that residue and perhaps warm that soil. In this example, we're using row cleaners to part the residue and those corn stalks from the previous year and get that crop in the ground to a consistent depth, get that seed slot closed, and obviously prompt uniform emergence. So that's a little bit about what we're going to be discussing here this morning. So from a point of view of the second major topic, this one is setting up a planter. Get a huge amount of questions on many different topics of planter setup, and a lot of these are beyond the scope of today's webinar, but in very general terms, we obviously need to start out with a heavy enough planter that's capable of no-tilling across your soil types, especially if you've got heavy soils, especially if you've got heavy residue. You know, a lot of these older planters don't have enough frame weight, and they really struggle to no-till into some of the heavy residue, harder soils. So obviously starting out with a heavier planter is obviously required. Make sure the toolbar is leveled. As you can see, make sure the drawbar is leveled. Top left-hand photo, there's so many examples as I drive around the country during planting season where growers are not leveling their drawbar, which obviously changes the orientation of the no-till coulter or the double disc opener, and more especially the closing system. The gathering action of the closing system changes as that closing wheel arm pivots up and down, and we'll spend just a few minutes on that later on. Top right hand photo shows a planter, a new 1795 with the ExactEmerge meter on it, new no-till coulters, new double disc openers, and I'm going to say that in most environments I think a no-till coulter hurts more than it helps. This is a bubble coulter, as you can see, which generally throws less soil, but we've seen some good examples last year when some of these higher speed planters were running, especially at higher speeds. You get running much faster than 6 or 7 miles an hour with a no-till coulter, even a bubble such as this. They really tend to throw soil out, especially in some of the higher moisture clay soils, even in drier conditions, similar to what we're showing here. If they start throwing soil out at random, then that soil gets under the gauge wheels, causes the gauge wheels to flap up and down, and before you know it, you've lost a lot of ride quality because that no-till coulter is kicking soil out. Obviously, this planter is considered a no-till planter, the one in the top right-hand corner, but it's not equipped with any residue managers. It has standard smooth wheels on the back, so there's certainly some improvements there to equip that to be ready for no-till conditions. Other basics, bottom left-hand corner, it's very important to make sure that the closing wheel arm and the closing wheels are centered directly over the seed slot, as shown here. And then bottom right-hand side, make sure all the drive lines are, this is a brand new planter, been delivered to the dealership, never been used yet, but this was the condition of the chains on it, not a good situation to be starting out. So just a little bit more detail regarding the no-till coulter. This is a wavy, as you can see, notorious for throwing soil out, as you can see in this photo. And when they throw soil out, not only is it specific to soil type or soil moisture, influencing seeding depth, obviously where it throws more soil out, it brings the gauge wheels up, which shallows up your seed depth. But the other challenge with the no-till coulters is when they throw soil out, you've not got soil on both sides of the seed slot, and you end up with a seed in the bottom of the seed slot without enough soil on both sides to gather it up, especially back with a pair of smooth wheels similar to what we're looking at here. So if you see no-till coulter,
Phil, it seems we've lost your connection.
here's another.
Do you want to repeat?
You've lost it altogether.
You're back now. I think
Okay.
the last 30 seconds we may have lost.
Okay, sorry about that. So no-till coulters, there's certainly a place for no-till coulters, but here is a good example on the screen where if you start seeing this, this is a good example where soil was thrown out of the seed slot with the no-till coulter, causing the gauge wheels to climb up over the soil. So here, for example, where the arrow is pointing to, this is where the soil was thrown out. Where the soil was thrown out, the gauge wheels climbed over it, which resulted in a soybean seed being thrown out of the seed slot altogether. So a combination of gauge wheels being lifted up by soil being thrown out and the jarring action of the gauge wheels causes loss of seeds placed within the seed slot. Certainly not a good example. And this is what some of the final stands can look like. So that in this particular example, the grower was using no-till coulters, no residue managed at all, and as a result of that, it's a pretty marginal stand of soybeans, okay? And it becomes even worse at higher speeds. So if you get up to 7, 8 miles an hour faster, like some of the manufacturers are advocating, these no-till coulters, even the bubbles, can be super aggressive. Certainly not what you want, and here's a good example, okay? And when that soil is thrown out, like I mentioned just a few moments ago, sometimes there's not enough soil on both sides of the seed slot to close that seed slot back up, especially with factory smooth closing wheels. So let's spend a few minutes here talking about no attachment. So this is a good example to start out. Okay, the left-hand side screen, so the left side of center, was a grower that actually used strip till. The right-hand side was no-till. So right off the bat, you might say, yes, the corn on the left-hand side is greener, healthier, has a better stand, is probably two leaf stages ahead of what's on the right-hand side. And at harvest time, the grower thought, based upon the yield monitor, that the strip-till corn was approximately 15 bushels per acre better than the no-till corn on the right-hand side. However, looking at this example closely and walking up and down the corn rows, there was certainly a lot of issues, and the primary issue here was that the planter was not set up for no-till on the right-hand side. So in this example, no residue managers were installed on the planter, and as a result of that, obviously we didn't get any warming effect from just parting the residue at planting time. So we got a lot of residue there, and there was even some examples. If you look at the middle right-hand side of the photograph, there's some areas out there with super heavy residue, so the residue wasn't spread very well at harvest time, and as a result of that, he had some stand losses because of the excess residue. So the bottom line here is, I think, and certainly I've seen a lot of good examples that would back this up, I think if you properly set up a planter to no-till, it will do as well as strip-till in most environments. Now, if you're way north, perhaps in the Dakotas, Minnesota, Red River Valley, maybe there's some examples up there in the higher moisture environment, higher clay content soils in which maybe strip-till has a place. But you get much further south of them areas, I really think a planter can be equipped to no-till and do just as good as a strip-till system. So we began a few years ago. Martin's developed the first ground drive row cleaner, Pinagist row cleaner, similar to what we've seen on the top right-hand corner. And these worked okay, but what we often see with a fixed row cleaner, like the one in the photo, is that they tend to be very difficult to adjust. And for example, if you look at the corn row on the left-hand side, you'll see that there's residue parted in this area. And then further up the same row, it's not parted at all. And you look at the row to the right, you can see there's an area parted and then not parted. And they're very, very specific to soil type, the angle of the planter relative to the topography of the soil. So the bottom line is they do okay, but what we're trying to do is part residue consistently without moving soil. And the fixed row cleaners struggle to achieve that. The only environment, in my opinion, where a fixed row cleaner is a good option is if you're no-tilling directly into 200 bushel corn stalks and you want a row cleaner up front to knock those tough BT corn corn stalks out of the way, perhaps in Nebraska or South Dakota, where there's not a lot of weathering over the winter months. That would be an environment where a fixed row cleaner would be a good option. But most of the research, and this is some comments from Ken Ferry, the research specialist from the Farm Journal group, he stated that for the third year running row cleaners so that they can float over the terrain improve yields compared to the same row cleaners pinned in the static position. In 2006, floating row cleaners added 10 to 13 bushels per acre to yield in no-till fields. After closely watching these row cleaners run and monitoring yields for the last 3 years, he said he was convinced that it's best to let the row cleaners with depth bands float and follow the contours of the ground in no-till fields. So just for an example, all right, this is a planter running in wheat stubble planting corn, as you can see, and there's still some growers out there that they believe vertical tillage is required. It's an option to warm soils and dry soils. And in a lot of examples, I've seen growers that were vertical tilling alongside a field immediately next door where the farmer was out there just no-tilling. So I think there's a lot of environments where the first time you can get across the field in the spring to vertical till a field, to till the field and warm the soils, I think that's about the same day you can get a suitably equipped no-till planter out there and start planting in many environments. So certainly something to be considering. But on the right side, this is a planter equipped with row cleaners, RID tires, spike wheels, drag chain, as you can see, in very moist soils. As you can see, soil is actually picking up on the spike wheels. But we're actually able to get those seeds in the ground in a timely fashion, get the seed slot covered up, get that seed slot leveled off with the drag chain, which is what we're showing here, compared to the row unit on the left-hand side that doesn't have any row cleaners. So you can just see that there's going to be a huge difference there in soil warming, and we'll discuss that here. And I'd certainly encourage anyone that hasn't got a soil thermometer such as this to get one. You can learn a huge amount about soil warming and soil temperatures and how the time of the day and many other things change as a result of moving residue. So for example here, we ran a planter equipped with row cleaners through this area of the field, and within approximately 1 hour of planting, we saw the soil temperature increase from 67.4 in the non-cleaned area, just below the thermometer box, to 74.8 within the cleaned area within the row. So about a 7 Fahrenheit difference in soil temperature within 1 hour of cleaning that row with the planter. Okay, and it's really useful, and we were measuring temperatures here 1 inch below the soil surface, and it's really useful to use a thermometer like this when we're doing research, because in many examples the soil temperature drops to close to the nighttime low and then re-warms back up the following day. So soil warming is really a daily effect. Especially if the sun comes out early in the day, you can watch and monitor and log soil temperatures based upon the time of the day. So when people are talking about strip till, warming the soil, almost every night that soil temperature at seed depth drops almost down to the nighttime lows and then re-warms back the same day. So just by lightly tilling the ground, moving the residue, such as what we're showing here, soil warming can be hugely benefited without the need of strip till. And not only warming the soil to promote uniform emergence and rapid emergence, I think as most everyone's aware, soil temperature has a huge impact on the availability of most nutrients, including phosphorus. So for example, a 14-degree Fahrenheit difference in soil temperature can improve the relative availability of phosphorus by 70%. Okay, so not only are we warming the soil to get the crop out of the ground, we're also warming the soil to increase the availability of nutrients. So we really like the floating row cleaners. This is the BCIH Martin 1360 row cleaner. It uses a pair of 13-inch wheels, 3/8 thick, heat-treated T1 material, 14 teeth around the outside. And the idea of this is just to part the residue without moving soil. This one is equipped with what we call side treader wheels. These are basically a depth band that limits the tooth engagement to prevent furrowing, which is obviously what we're trying to avoid. And this is obviously equipped also with the optional cam adjust, basically a simple push, rotate, let back down again, and it allows you to control the lower travel point of the row cleaner. So if, for example, you was going from a no-till field to a conventional field, you would have to carry more weight on that cam, transferring the weight to the row unit. But in most no-till conditions, we would let the row cleaners down to the full floating position. So let them all the way down with enough travel to float up and down as the soil topography changes. All the Martin 1360 row cleaners come with what we call internal deflectors, which are basically a scraper. In this particular image, we're showing both wheels in the front position, which enables them to be interlocked, which gives you traction out to both wheels. The other thing that the side treader wheels provide is traction. So as long as you can keep those wheels turning, you can eject residue with the internal deflectors, which are a good feature. If you haven't already got these installed, they're definitely a good feature in high residue conditions, especially tough residue conditions. So this kind of shows you what we're trying to do from a point of view of parting residue. In this example, we're just planting corn into soybean residue, pretty light residue. All we're trying to do is clear a band 4, 5, 6 inches wide in light residue. And in this example, we've got one row cleaner wheel forward, the other one retracted, and basically carrying some weight on the cam adjust. So the teeth don't engage the soil. They're just designed to move residue. So that's kind of what we're trying to do from a point of view of trying to achieve uniform emergence, scratching the soil to warm the soil and get the crop out of the ground. Floating row cleaners are most beneficial rolling ground. Here we see a Kansas crossing over a terrace, okay? And you can see the floating row cleaners following the ground, following the contours, and they will achieve a much more consistent standard of residue movement than you'd ever see with a fixed row cleaner, okay? This is one of the more challenging environments. So this is a grower that's planting double crop soybeans. This grower was actually in Kentucky. This grower was planting double crop soybeans right after wheat harvest, and this was 90 or 100 bushel wheat that wasn't chopped. This had actually been through a spreader, but we really encourage growers to use choppers wherever they can. But this is just a straw spreader, and the residue wasn't spread the greatest either. But this is really a challenge to try and plant into, to try and part the residue and get a uniform emergence of a soybean crop. So row cleaners can certainly help in these environments. Here you can see a floating row cleaner parting the residue, as you can see. As the residue gets heavier, we really encourage producers to use what we call wheel weights. Each wheel weight weighs 4 pounds. So you can put 2 wheel weights per row or 4 wheel weights per row, which basically puts your weight on the row cleaner wheels where it's required. You're not having to transfer any weight to or from the row unit. So it's basically independent of the row unit, pushing ahead of the row cleaner, or pushing ahead of the row unit, I'm sorry, helping to clear residue. The other thing that row cleaners do for a lot of people, and you know, some people buy vertical tillage tools and operate vertical tillage tools to take out wheel tracks from combines, grain carts, etc. And in many examples, you can actually, by letting the row cleaner down, especially with wheel weights, you can actually clear a little strip, work a little strip, level a little strip with the row cleaner, and in addition to clearing residue beyond the gauge wheels. So a row cleaner will help you in this regard if you want to let it all the way down. So basically doing the job of a vertical tillage tool. So there's always a lot of questions and a lot of debate about RID tires. My opinion is if you're planting in higher moisture soils, I'm absolutely convinced that the RID tires are a huge advantage. They basically allow the sidewall to raise up, eliminating some of the sidewall compaction issues that you can see with a flat gauge wheel tire, which is on the left. The RID tire, as you can see, is on the right-hand side, so we've got two different tires just for demonstration purposes on the same planter. So I'm a huge fan of RID tires in moist soils. If, however, you're in the Central Plains, you're planting into dry soils, these are probably conditions where we wouldn't recommend an RID tire because the sidewall can flex upwards, seeds can get positioned in that little void where the sidewall flexes upwards, and that's not good from a point of view of keeping that seed in the middle of the seed slot and pressing it down with a Keaton seed firmer. I'm a huge advocate of the seed firmers. I think in most environments they absolutely help. Basically what we're trying to do is just push those seeds, lock those seeds into the bottom of the seed slot, which is obviously very important when you're using spade-in closing wheels. Obviously, spade-in closing wheels do not offer a lot of vertical compression of the soil surface by design, so it is important to lock or imprint those seeds into the bottom of the seed slot with a Keaton seed firmer. Generally, for the first year, with the new Keaton seed firmer, they have sufficient downforce to press the seeds down. Generally, the second, third year, etc., they lose most of their tension, and you can get a little bit more life out of the Keaton seed firmer by adding a mojo wire which presses that seed firmer back down again, which will help you wear out the seed firmer and before they need to be replaced. So yeah, I'm a huge fan of Keaton seed firmers. So moving backwards to closing wheels, here you can see a good example. No-till soils, no residue managers. You can see there's some soil thrown out behind the closing wheels with the no-till coulter, which isn't good. But in higher moisture soils, especially higher moisture clay soils like this, a standard pair of smooth wheels like this really don't do the job very often. Even with maximum pressure on that closing wheel arm assembly at the back, they're not going to close the seed slot consistently. So Martin makes a number of different closing wheel options. This is a pair of 13-inch closing wheels. We call this the 1344. So two 13-inch wheels. Basically, on the closing wheel arm, in this example, it has the drop-down kit. So there's basically a small steel bracket, as you can see, from the hub ball up to the closing wheel arm, and that helps level the closing wheel arm assembly, which is pretty important. For example, to get maximum closing action from any planter closing wheel, it's pretty important that the top of that closing wheel arm assembly is level, meaning it's horizontal with the surface of the ground. As the rear of that closing wheel arm descends downwards, you begin to lose closing action, as I'll show you in just a minute. So here's a good example, very wet soils, but the 13-inch wheels are able to close that seed slot basically from the bottom upwards. So the spike wheels are engaging the soil, they're separated far enough away from the seed so you're not touching any seeds. So you're basically creating seed-to-soil contact at seed depth, leaving loose soil above the seed, which is obviously good for promoting rapid emergence. The drag chain is pulling behind, leveling the seed zone, leaving a nice soil finish to promote uniform emergence and uniform soil warming. So from a point of view of leveling the closing wheel arm, here, for example, is a level closing wheel arm. The top of the closing wheel arm is level with the ground or the concrete floor in this example. And here you can see we have some gathering action, meaning if you look directly from above looking downwards, you have some gathering action to close the seed slot when the top of the closing wheel arm is level. However, there's still a lot of planters out there in the industry. When I'm riding around in the spring, there's still a lot of producers out there that have their closing wheel arms descending downwards, something like what's shown in this photo. And if the closing wheel arm descends downwards, then you lose gathering action. And in this example, we're actually parting the seed slot, so you get absolutely no gathering action at all. So make sure that whatever closing system you utilize, make sure the closing wheel arm is level to achieve the highest standard of gathering action and slot closure. So you can close the seed slot very well with either a pair of 13s or a single 15-inch wheel, which is what this one is. So here we're showing on the right-hand side, we've got a single 15-inch wheel alongside a smooth wheel on the opposite side. And this works good in what I consider to be medium moisture soils through drier soils. In higher moisture soils, I'd certainly recommend the pair of spike wheels, similar to what we showed just a few moments ago. Here we're showing a producer that's dribbling liquid fertilizer down on top of the soil surface behind the smooth wheel. And this is actually a mix of 1034O and UAN 28%. And I would certainly encourage anyone that's looking for higher yields to certainly get that fertilizer in the ground below seed depth, because obviously nitrogen will move, but because this grower was putting 1034O phosphate on top of the soil surface, I think most everybody's aware that phosphate is basically very immobile in the soil. So by putting phos on top of the soil surface, it's not going to move down into the soil very far to help that corn crop. So as that corn seed is placed in the ground, for example, 1.5 inches deep, and those roots grow outwards and downwards at 30 to 40 degrees of an angle, we need to get a band of fertilizer, especially nitrogen and phosphorus, to the side of that corn seed and underneath it. So as that corn plant germinates and begins to root outwards and downwards, it picks up that nitrogen and phosphate as it's moving down into the soil. By placing phos on top, you've really got limited benefit out of that phosphorus. And if you're putting it on top also, the nitrogen component is obviously going to be more susceptible to losses if you don't get a rain through nitrogen losses, okay? So from a point of view of fertilizer placement, I see a whole lot of advantages to getting nutrients such as nitrogen or nitrogen and phosphate blends in the row to the side. So here we're seeing a John Deere opener equipped with a Martin 1360 floating row cleaner, and within the row cleaner is there a UMO 100 unit mount fertilizer opener. And this opener basically gives you 9 different positions. You've got 3 horizontal positions, 1, 2, 3 inches away from the middle of the seed row. Then you've got 3 vertical positions in which you can position fertilizer 3/4 above, even with, or 3/4 below the seed row. So in this example, providing you've got a planter heavy enough to mount these on, which is obviously most of the newer planters, we can include those, but not the older ones, it enables us to place a band of fertilizer off to the side very efficiently and cleanly in a band, so when that corn plant begins to grow downwards, it hits that band of fertilizer, okay? So a good example of a system, a planter equipped to no-till in heavy residue corn on corn in this example. Dr. Lloyd Murdoch allowed me to use this research. I've been corresponding with him, finding out a little bit about this research, but I think there's a lot we can learn. This is some research that Dr. Murdoch conducted at the University of Kentucky at the Princeton location. It's basically a Zanesville, Fragipan soil, and while the corn yields were not super high, I think it offers a lot of insight from a point of view of a lot of the principles that we have discussed this morning. For example, the first row of data refers to chisel and disc. Okay, so chisel and disc tillage, no row fertilizer was placed in the row, no row cleaner was utilized, and the yield at harvest time was 132.1 bushels per acre. Okay, the next line down was no-till. Okay, without row fertilizer, without row cleaners, that was a 114 bushel per acre yield. Okay, so immediately a lot of guys are going to say, well, that no-till doesn't work, we've got a yield lag, but let's look here at more detail. Okay, let's add row fertilizer. So as soon as row fertilizer was added, that gave us a 9 bushel per acre yield increase. as soon as row cleaners were added, that gave us a little over a 17 bushel per acre advantage. And when row cleaners and fertilizer was added, it took the yield up to 136.9, which is higher than the tillage environment earlier on without all the fixed costs of owning and operating the tillage equipment. So there's a lot going on in that slide. I'd encourage you to look at that in more detail, but I think there's a huge amount of opportunities to set up a planter properly to no-till, and that would obviously include residue managers to part that residue to give you better ride quality, in addition to placing fertilizer in a band alongside the row. This is what I think the future is going to look like. Maybe not exactly like this, but I think what you're going to see more and more all the time are new and innovative ways of delivering fertilizer in a band at planting time. Obviously, if you can place nitrogen, phos, and other elements in a band, you've got more efficient utilization of those nutrients. So right off the bat, I think growers need to always be looking at better ways to manage their nutrients, and this is a way of doing it. Now, this isn't going to work on steep slopes, but for growers in flatter areas, I think this is an excellent concept that's really, really evolving in a lot of areas. This particular producer is in central South Dakota, 16-row deer, central commodity system, as you can see, pulling a 1910 3-compartment cart equipped for row crop applications, basically giving him the ability to plant, to place NPK in a band alongside the row. Okay, in this example, is using dry, and in most environments, you get the biggest bang for your buck from dry fertilizer. For example, last fall, dry MAP or DAP was around 50 to 55 cents per pound of P2O5. You compare that to 1034O, and it's almost twice that, not quite, but you can get a lot more phosphate per dollar when you're using dry fertilizers compared to liquids, okay? So I really think this is where the industry is going. So we're parting residue with residue managers. We're closing the seed slot up in higher moisture environments with better closing systems, and then we're placing fertilizer in a band alongside the row. So this is what I think the future is going to look like. I think you're going to see a lot more options. Hopefully we're going to see more planters that are equipped to handle dry fertilizer on a single toolbar, hopefully allowing you to spread some of that weight from the center section out to the wings, so you don't have to add weight out to the wings. So that basically concludes the presentation. I'm going to pass it back over to Dave to open it up for questions.
Thanks, Phil. Now for the Q&A portion of the program. We've had a lot of questions, by the way, and we'll get to as many as we can. In any case, Phil will be sent all of the questions, and we'll get answers later on if we don't get to them today. The first question, speed and accuracy, can you have both? And what is the most important improvement I should consider in relation to precision ag?
That's a good question. So speed and accuracy, can you have both? I'm going to say yes, you can have both if you hold your speed to a reasonable speed, and it obviously depends on the soil conditions. If you look at the John Deere 1795, 1775 marketing materials, you know, they're advocating the 8, 9, 10 miles an hour forward speeds, but in almost every example where I've seen their marketing materials, they're all in conventional soils. They've all been just worked powder fine, the zero residue. So in those environments, I think speed and accuracy absolutely can be obtained. I feel pretty good about most of the high-speed meters. There's some really good high-speed meters out there. There's a lot of good ones in Europe. John Deere has one also, and they're going to allow you to singulate seeds. I don't think that's the challenge. The challenge is when you try to singulate seeds on a no-till planter, when you got tractor wheel tracks, combine wheel tracks, you've got rocks out there, the wheels start falling off when you start going faster than 5, 6, 7 miles an hour, in my opinion. So those are the challenges. So I think speed and accuracy can be obtained, but it's really going to be I think it's really going to be a challenge in a no-till system. A lot of no-till planters are not heavy enough. Even with some of the new no-till planters we've seen running at higher speeds, without adding a lot of weight to the units are riding out of the ground. So I think speed and accuracy can be obtained in certain conditions, but we're absolutely up against some barriers from a point of view of downforce and capabilities of a row unit to work in wheel tracks and rocks. The other part of the question, what's the most important improvement to add from a precision ag perspective? I sound like a 2020 salesman for precision planting, but I've absolutely learned so much from the 2020 monitor. I know there's a huge amount of growers out there that use them, that have used them for a long time, so I'm probably speaking to the choir from a point of view of promoting them to everyone. But they teach you so much about the planter, ride quality, consistency of downforce based on different soil types, different topographies, different residue levels, how they all interact. I would absolutely start by putting a 2020 type system on a planter and monitoring what you're doing to make sure you've got all of the pieces in the puzzle that you need to get uniform emergence.
Okay, our next question. What fertilizer or other inputs would be best for return per acre applied with planter for corn or beans, dry or liquid?
I mentioned in the presentation just a few minutes ago, in most examples, not all, but in most examples, dry fertilizer is going to be significantly cheaper than water. Now that's than liquid fertilizer, I mean, just because you've got that water that you're carrying and the volumes are higher. So dry fertilizer is going to be cheaper than liquid fertilizer. So I'm a huge fan of dry, but it's not for everyone. It's going to take a whole setup like I showed in the presentation just a few minutes ago, something like this. It's going to take a complete tendering and logistics system to take advantage of that cheaper fertilizer price. I'm a huge fan of banding fertilizer, but I really absolutely think it starts with a good set of soil samples, get good soil tests, begin to understand the levels of nutrition within your fields, within different regions of the fields. And I think a system like I'm showing on the screen right now could work very, very well in combination with a region sampling system. For example, one half of a field may have been managed differently over time to the other half of the field. And as a result of that, one half of the field's got low phosphate, the other half's got high phosphate. So being able to tether a variable rate type system, similar to what we see on the screen, to dry fertilizer at planting time, banding it, there's a lot of positives that add up to make a big difference here. So I would absolutely start by looking at different ways to place fertilizer to increase fertilizer efficiency, couple it to variable rate based on soil tests.
Yeah, another question just came in related to variable rate, and I think you've answered it, but I'll ask it. Can the dry fertilizer on planter be variable rate applied?
Yeah, I mean, any air cart or most metering systems, such as what we're showing here in the photo, absolutely, they can be set up to do variable rate. So you can do variable rate, you can do variable rate liquid or dry. Most of those systems are in place, and that's a very good option, okay?
Okay, next question. How do you manage cold, wet spring to get heavy soils to warm up and dry out so you can even get the planter, so you can get the planter to do a good job?
And I think a lot of that depends on the region, the rainfall, the soils, but I feel like there's a lot of producers out there that are running like a vertical tillage tool to dry out the soils, when in reality, the first day you can be out there and it's dry enough to run a vertical tillage tool, you can pull out the pin on the vertical tillage tool and hitch to a suitably equipped no-till planter and start planting. Now that doesn't work everywhere, but I'm going to say in a lot of areas, absolutely that will work, okay? So setting up a planter with residue managers, with spike wheels, drag chain at the back, and placing fertilizer so you got more availability of PK and other elements in a band in close proximity to that seed So when it germinates and begins to spread its root system out, it's hitting that band of nutrition. So I think that's more a component of managing cold soils, is getting that fertilizer placed. So in some of them environments, the growers need to be looking at a pop-up, maybe some liquid fertilizer in the row, and then a band of PK, N off to the side, similar to what I'm showing in the photo here, would be a good way of addressing some of them concerns, in my opinion.
All right, the next question. Without spending any dollars, what is the single biggest improvement or adjustment I can make to my no-till drill?
Without spending any dollars, I would say the first thing I always tell growers, you learn a lot by looking. What I mean by that is, just get off the planter regularly in different parts of the field, check your seeding depth. Check your seeding depth in the higher areas of the field, assuming you got rolling ground. Check your seeding depth in different soils, just to make sure that the planter is performing as you want it to. For example, you might have some ridges, some eroded soils, more clay towards the soil surface. The soils are tighter. And in those environments, your planter may be riding out of the ground. You may have zero downforce on your gauge wheels. So in those areas of the field, seeding depth may be compromised and you've got very shallow seeds. So I would say by monitoring a planter, get off frequently, look and see what's going on, that would certainly be one of the most important things I'd suggest. Again, we're back to 20/20 type systems. You can sit on the tractor while you're planting and monitor a lot of these aspects. So it's just a peace of mind, but a better understanding of what you're doing. Other things to think about, I mean, I know you said without spending a lot of money, but there's a lot of producers out there that probably need to spend some money. It's just justifying it in their own minds that they need to spend it, but they absolutely need to begin with a well-adjusted planter, making sure it's got disc blades in good condition, make sure the gauge wheels are tight up against the double disc openers, make sure there's not a lot of play in the linkages, the pivots, the pins in the planter unit. I mean, some of them things do cost money, and it may be more of a, it may be costing you more in having the planter that's in poor condition than what it would cost you to upgrade it and get it into tip-top shape.
Okay, next question. How do you properly set down pressure, and what effect does this have with seed placement?
Okay, so obviously you need consistent contact with the gauge wheels against the soil surface across the field, across different soil types, across different topographies, etc. So a good way of doing it is to monitor it electronically with the systems that we've already discussed. If you don't have such a system, I would certainly encourage you to get off at regular intervals within the field and grab a hold of that gauge wheel. You should be able to turn that gauge wheel when it's lowered in the field position. You should be able to turn that gauge wheel with firm force. If there's so much down pressure on that gauge wheel that you have to really pull on it, it takes most of what you've got to pull on it, you've got too much force on those gauge wheels. Too much force on the gauge wheels, especially on on soils more susceptible to soil compaction, is going to result in a whole lot more sidewall compaction. So in moist soils, we'd certainly encourage producers to consider RID tires. That's allowing that sidewall to flex upwards, similar to what we discussed a few minutes ago. But controlling your gauge wheel down pressure, especially on moist soils, is very important because you don't want to over compact the sidewalls. So a combination of watching, adjusting, in conjunction with using RID tires, I think is a huge piece of the puzzle in higher moisture soils. So I think that's probably all I can say on that topic, Dave.
Okay. Next question. How can I better adjust a rental machine for clients? Some plantings do not come up well, while others do come up well.
So a lot of that goes back to what kind of condition the planter is, if it's a rental machine. I mean, there may need to be some money spent on it from a point of view of disc blades, residue managers, add in some of these things. But once you get that machine in the field, just make some test passes in the field. See what your depth looks like, see how consistent your depth is across different soil types, making sure the closing wheels are installed properly, they're aligned properly, the planter is leveled to the point in which you're creating a clean seed slot, you're getting that slot closed. And also, I didn't mention this earlier on, and a lot of people do this, it's not new to most people, but just holding that closing wheel arm assembly up with a rubber strap or a tarp strap and making, a 10-15 foot pass, looking at the metering of the seed, looking how cleanly that seed slot is made, looking how well those seeds have been positioned in the seed slot, looking to see how the seed firm is working, if it's got enough down pressure in it to press those seeds in the bottom of the seed slot. So just by pulling up or holding up the closing wheel, you can learn a lot regarding how cleanly that seed slot's been created, how the seeds have been placed in the soil. Then you can make some more test passes by lowering the closing wheels back down and comparing the performance again. So it's all about looking. The more you look, the more you learn.
Okay, the next question. I have an older Case 950 planter with clean sweeps. I farm a small acreage and can't afford one of the new planters. What would be your recommendation to enhance my planter?
So I don't know the soil types, but a 950 is is a pretty old planter. You're going to be limited on a 950 from a point of view of how much downforce you can convey from that frame to the row units. So if you're planting into higher moisture, harder no-till soils, I would be a little concerned about getting that planter in the ground consistently. You may have to add weights to the wings. Obviously, in longer-term no-till, the soils become more mellow, but in early years of no-till, some of them ridge tops, the eroded ridge tops, can be really hard and difficult to penetrate. So with an older planter like that, sometimes it's a challenge to get those disc openers in the ground to a consistent depth. So I would be looking at potentially adding weight. I don't know the tillage practice, the soils, or the long-term, or how long it's been in no-till, but a combination of weight and making some stops and checking seeding depth would certainly be my recommendation, okay?
Okay, next question. Regarding RID gauge wheels, can you explain the benefits of the narrow gauge wheels, especially in moist soils?
So narrow gauge wheels are preferred, especially for producers that are seeding narrow rows. Assuming a grower's planting 15-inch rows, it may have a 1790 John Deere or a 3600 series Kinsey, in which he plants his corn on 30-inch rows and his soybeans on 15s. If you've got residue managers on front and back ranks of a 15-inch row planter, and you get going very quickly at all, some of that residue moves out far enough in which it's the gauge wheels on the rear rank start climbing up on the residue that's been moved by the front rank. There's some things that we can do with the row cleaners to narrow up the angle, which stops you throwing residue as far. However, you're not clearing a band wide enough for the gauge wheels to run in without climbing up on residue. So in those environments, narrow gauge wheels help you because you can run a row cleaner with a narrow internal angle, which lets the residue not be thrown as far, but the gauge wheels can actually operate within a narrow band of cleared residue, if that makes sense. So especially on narrow rows, especially on planters that are running at higher speeds, you want to take some of that angle off the row cleaners, and because the band of cleared residue is narrower, narrow gauge wheels really help in that regard. And you can get narrow gauge wheels with some RID characteristics that give us the same benefits as we discussed here this morning in higher moisture soils by not compacting soils immediately next to the seed slot.
Well, we have received several other questions, but we're out of time today. Today's presentation and audio will be available on the Farm Equipment and No-Till Farmer website, so you can go back and review it. The additional questions will be sent along to Phil, and we'll post them when he gets back to us with his responses. Watch your email as well as Farm Equipment's eWatch and No-Till Farmer electronic newsletters for more information. On behalf of Phil Needham, Martin Till, and the staffs of Farm Equipment and No-Till Farmer Publications, thank you for joining us today. When you leave the webinar, a short survey will pop up. Please let us know what you think of this live event, and as always, let us know what future topics you would like to see covered in upcoming webinars. Thanks again for tuning in, and make it a great day.